Okay, so we are going to graph a function rule. So because I'm telling you that these are functions, we know that they are going to pass the vertical line test. And more specifically, what we are working on is linear functions. So all of these have exponents of 1. All the variables have exponents of 1. Keep in mind also, we could be talking about this as f of x equals x minus 3. That's another way we could be writing this, looking at x and f of x as our table. So f of x is also the same thing as y, and this is also input and output. So what I put in, what gets spit out, okay? So if I am putting in a 0, for example, so if I put a 0 in here, y equals 0 minus 3, so y equals negative 3. If I did the same thing for f of x, remember this is also the same thing as y. I might pick 1. So if I input 1, so if I put a 1 in for x, I end up with y equals negative 2. And we like to have 3 or more points. So we will do another one. Let's put in 2 since we're continuing that way. So if I have y equals 2 minus 3, so y equals a negative 1. So if I put in a 2, I get an output of negative 1. You should see a pattern. So you should see a constant pattern in the x column. I'm adding 1 every time. You should see a constant pattern in the y or the f of x or the output column. So from negative 3 to negative 2, I am adding 1. And from negative 2 to negative 1, I'm also adding 1. Okay, so when we are graphing these, you are graphing these as ordered pairs. So 0 and negative 3, 0, down 3, 1 and negative 2, and 2 and negative 1. That is actually supposed to be a line. Okay, so this is what our function graph would look like. If you look at example 2, so if we have x and y, or x and f of x, however you want to look at it, this one's a little bit more challenging, and a lot of you are kind of freaking out right now because of this fraction. What you need to remember is it's the fraction we don't like. Okay, so we just need to pick out good numbers that would help me get rid of it. So if I put a 0 in for x, I end up with 2/3 times 0 minus 1. Well, what happens when I multiply the 2/3 and the 0? It gives me 0, subtract 1, which gives me a negative 1. So an output of negative 1. I'm just going to write the equation down again over here. If I put in, let's say a 2, or even a 1, let's say a 2. If I put in a 2 in here, so let's just visualize this. Please do not write this down. What happens to my fraction? It gets made into a nastier looking fraction, right? Because I picked a 2. Well, what happens if I pick a 1? Well, now I end up with 2/3 times 1. That's not getting rid of the fraction. So what kind of numbers would I want to pick for my input that would help get rid of that fraction? How about if I pick multiples of 3? So if I put a 3 in there, the 3's are going to cancel out. And then I end up with y equals 2 minus 1, so y equals 1. So if I input 3, I get a 1. What might be another good number to pick? You could pick 6. So if I put in 6, 3 goes into 6 2 times. 2 times 2 is 4 minus 1, so y equals 3. So another good number to pick might be a negative 3 or a negative 6. Okay, so for our purposes right now, we're going to focus on 3 points. So 0, negative 1, 3, 1, and 6, 3. Okay. And lastly, we have this thing with absolutely no numbers whatsoever. What this graph should be telling you is that whatever y is, so is x, and vice versa. Whatever I put in, that's what gets spit out. So if I have a 0 for my input, well then y has to be 0. If I put in a 1, so y equals 1. 2, 2, 3, 3. I could do that till I'm blue in the face. 4, 4, etc. So 0, 0. 1, 1. 2, 2. 3, 3. And I would have that kind of a graph. On all of these, what you should be noticing, and we will talk more about this when we get into the next unit, but all of these are increasing. So if we are, say we are walking here, we're going to be going up the hill. These are increasing. Sometimes we will talk about a rising slope. If you have a graph going the other direction, these might be called falling, might be called decreasing, falling, might even be called a negative slope. We'll talk more about slope. And we're going to say a positive slope up here. Okay, so that's what you're doing when you are graphing a function rule. So you should end up with lines. Now, in real life situations, if we are graphing and we are talking about the number of people and we'll say the cost of groceries. Okay, so we kind of assume that the more people that we have in a household, probably going to increase the cost of our groceries. But if we had 0 people, we would have 0 cost of groceries. I think we can all agree on that. And as the number of people go up, so does the cost of groceries. However, if this represents 1 person and 2 people, 3 people, 4 people, and 5 people, are we going to have 1.5 people? So this might be, if you have 1.5 people, you might be spending, I don't know, $40, for example. Are we ever going to have half a person or a third of a person? So this would be a situation when you would want to have a different kind of graph called a discrete graph. Let's spell it. Okay, so we would need a discrete graph, which would be the same situation. Let's do the number of people and the cost of groceries. Okay, so if we have 0 people, we're going to have 0 cost of groceries. Let's say this is, we'll make it cheap, $10. $20, $30, $40. So if I have one person, it might cost $10. If I have two people, let's say it costs $20. And three people, we'll say $30. And four people, we'll say $40. This is a situation when we would not, quote unquote, connect the dots or draw a line through those because, like we talked about up here, you're not going to have 1.5 people or 1.8 people. So this is called a discrete graph. That's just like when you go to the grocery store, you can't buy 1.5 packages of cookies. You have to have either one package of cookies or 2 packages of cookies. So again, depending on the situation. When you have a line that is connected, like you've seen in some of the other graphs that we have done, this would be called a continuous graph. So a continuous situation, we'll be talking maybe about money or time. We can have minutes and seconds and parts of an hour. We could have parts of a dollar using pennies, nickels, and dimes, but we're not going to have parts of people. Okay, so 2 different kinds of graphs, discrete and continuous.